Okay, so today we're going to look at the last methodology for solving quadratic equations. And so to begin with, we're going to try and solve this quadratic equation. So I've told you nothing on how to do anything. So I said, if I want you to solve this equation, we have two methods for us available to us. We can use the factoring technique, or we can do completing the square. So the first thing you look at is, can I factor this thing? I've already solved it, so for the sake of time, I'm going to go ahead and show you how I solved this and walk you through it. So here it is. So take out the, because it was negative, if I take out the negative sign, because it's, you want the square term to be positive, I look at this and I say, well, can I factor this? Is there any factors of 1 and 3 that will subtract and give me a 5? And there's absolutely no way that's going to happen. So this cannot be factored. So the other option then is to put it in completing the square format. So this is the state method, for lack of a better terminology for it. So you have to make this a x squared positive, an x squared. So we have to divide everything by, in this case, be -3, because we want that negative out there too. And so dividing all these terms by 3, -3 gives me this right here. Okay, this is the original one divided by -3. So here's the original. But divide each of those terms by -3, I get that right there. Okay. And so these two terms we're going to use to help complete the square. This is the constant that's going to get moved out to the side and then create the new constant at the end. So I need to take the middle term and divide it by 2, and that's going to give me 5/6. And so that's where I'm at here. So cut this in half. That's 5/6. It's -5/6. And I'm going to square that and put it right here like that. And then immediately subtract the exact same thing. So these two things will combine and become the constant part at the end. These three things will complete the square and allow me to write it as a binomial squared. So in doing so, the reason why I kept the negative here is because this is the number that goes into the binomial down below, giving us x minus 5/6. So that number just comes down into here. Okay. Everything else is the same. I cleaned this number up, found a common denominator, and made 1/3 into 12/36, so that I can combine those easily. And then I'm also going to redistribute to -3. Okay. In doing so, I get this right here, -3 times that quantity. And then this combines, gives me -37/36. And then I'm going to multiply that by -3, which gives me +37/12. So this original equation becomes this equation. And we've already solved this. So then I'm going to basically subtract that from both sides and divide by the -3 and produce that right there. Okay, and you can go slowly and work that out yourself to show that this is where you end up. And we talked about how do I take the square root of both sides. So to undo the square root, I take the square root, be a plus or minus in front of this when I do the square root, and I get that. And this right here can be simplified. The square root of a fraction is the square root of the numerator, and the square root of the denominator, and the square root of 36 is 6, which is why it's written this way. You want to simplify your radical as best as you can. So I want to know what x equals, so I'm going to add a 5/6 to this fraction over here. I'm going to put it in the front. I can't combine them exactly because of the square root, and so I write my answer in that form. So that is the solution to the original quadratic equation. Okay, so that's what this part here was about. So this is just practice and getting our minds back into the complete the square format. And so that's what that one did right there. And then I have another one. So again, when you're solving a quadratic, the first thing that you should be thinking of is, can I factor this? That is the quickest method for finding solutions, is the factoring technique. And as of this moment, if I can't factor it, then I have to do completing the square. Okay. So again, I did this one for you also. Let me show you and walk you through what I did. So the first thing I did in this example is I checked to make sure that I could factor it. I found the factors of 2, the factors of 4, and there is no combination that will allow me to add to get a 7. I can subtract and get 7 with these two, but I have to add to get a 7, so I can't factor this. I know I can't factor it. So the only option I have left is completing the square. In this one, I'm going to use the method I talked about, my method, which is simply to put it into vertex form. So I'm going to find the vertex. So from here, this is the A, -7 is B, and that is C. So the x-coordinate of the vertex is -b over 2a. So I plug these numbers into this, and I get a positive 7/4. That's the x-coordinate. Take the 7/4 and plug it into that, and then work it out, and I get a -17 over 8, and that is the y-coordinate of the vertex. The leading coefficient is 2. So with these three numbers, I can just put it into vertex form, and I get that right there. There's the A, there's the H. It's always x minus h, and that's h. And then it's always whatever that number is on the end. Okay? So, as you can see, a little bit easier, in my opinion, technique to get to here than doing all that. Okay? So, now I just do the same thing we did before. I'm going to add that to both sides and then divide by 2. When I do that, I end up getting this right here. I'm then going to take the square root of both sides. Don't forget the plus or minus on this side. And I get that. You want to simplify your radical. So the square root of a fraction, the numerator is the square root, the denominator gets the square root, and the square root of 16 is 4. We're going to add the 7/4 to both sides, and there we go with that. Okay? So again, completing the square process does help us solve equations that are more complex, that do not factor. But this is a long process, okay, as you can tell, in the sense that I have to do this process every single time. And it's the same process over and over and over and over and over again. It takes a lot of time. Is there a way we can do this right out the gate? If I give you a quadratic equation like this, and I can't factor it, I always want to try and factor first. It's always the quickest, okay? Then can I do something that's faster than completing the square? They can get me to this answer as quickly as possible. And so what they did, mathematicians did a long time ago, is they did the complete the square process with a generic quadratic equation. And I'm going to do that for you right now. I'm going to walk you through how they did it so you can see how they did it. And here we go. So I'm going to solve an equation using completing the square process. Zoom out just a bit. And I'm going to use it with this one right here. I'm going to solve that quadratic equation with those unknowns in it, A, B, and C. And we're going to generate a formula that will get me to the final answers just by plugging into the formula, okay? By knowing A, B, and C. And the process we use is exactly the same as the complete the square process. And we're going to do the complete the square process, the state method, to show you how they come about doing it, okay? You can still do it the way that I did it. Finding the y-coordinate can be a little bit tricky if you're not used to it. But here's what you would do from using the state process for complete the square. So the first thing I want to do is I want to factor out that A. So A comes out. I'm left with x squared. And then I divide each of those by A. So this is going to be B over A. And then plus C over A. Okay. We're going to bump this out a little bit, make some room in between. And we're going to do completing the square with these two terms and putting in the third term that I need to complete the square. So that's going to be x squared. There's B over A. And then I have to cut it in half. Cut it in half. And square it. So there's B over A cut in half, squared. And then I immediately subtract the exact same thing. And then it's just plus C over A. So remember, these three terms right here become the perfect squared. This is a perfect squared trinomial. So I completed the square. So I can write it as a squared term. And then these things over here are going to get combined together into a number. So here's A. This becomes x plus b over 2a squared. And then this over here is going to become, I'm going to multiply it all out, so I'm going to get b squared. I'm going to have 4 and an a squared. And then this over here is going to be c over a. And I'll just write it as c over a for now. So we want to combine these things together into a common denominator. Okay? The common denominator is going to be 4a squared. So I'm going to need to multiply the top and bottom of this fraction by a 4a. And again, I'm just going to do this extra step so you can see all what's going on so you don't get lost in the fraction. I'll get b squared. This will be 4a squared. This will be 4a times c. And this on the bottom here will be 4a squared on the bottom. So now these two things can combine into one fraction. And you have to be careful doing it, but it can be done. And I'll show you here how to do it in just a second. And I'm going to get b over 2a. Okay? And so if I flip these around so that you don't mess up with the signs, then you're going to get plus. Now I'm going to have a fraction that's going to have a 4a squared on it. This will be in the front, and this minus b squared will be in the back. And that's basically add the tops together. I could have put the b squared in front, make it negative, and that's fine too. But I just like it this way just because I don't like to have double signs next to each other. All right? So then we're going to distribute the a back through like we did in the other one. So then this will be a times x plus b over 2a squared. Plus, and then a times this is going to cancel out or reduce one of the a squares, one of the a's from the a squared in the bottom. So I'm still going to have 4ac minus b squared. And on the bottom, though, it's just going to be 4a. Because one of those a's reduces one of those a's down on the bottom. All right, so now we have it into basically vertex form. So I'm going to subtract this quantity to the side, and then I'm going to divide by a. So in doing that, you get this right here. And this becomes a negative and a fraction would be 4ac minus b squared. So I'm going to put this in parentheses here just so we don't confuse the signs. And then I'm going to get rid of this a by multiplying both sides by a. So I'm now going to multiply by 1 over a. I wanted you to see it that way so you can see what's going on. So I'm going to show you how things are going to be moved around. This stays the same. So I have this a, so it's just going to make an a squared on the bottom. This negative sign is going to distribute throughout the top. And I end up with is b squared minus 4ac on top, and then a 4a squared on the bottom. So that's where I'm at now. Undo the squared by taking the square root of both sides. And so now I have x plus b over 2a plus or minus the square root of all this. But just like before in the problems we did, we want to simplify this. The top, there's nothing you can do, so it's still going to be plus or minus. We'll put the square root on top. All that's under the square root. But the bottom, this is a perfect square. The square root of 4 is 2, and the square root of a squared is just a. So now I have that. Subtract b over 2a to both sides, and I get x equals negative b over 2a. Then I have a plus or minus the square root. And that's all over 2a. See, now that it's the same fraction, common denominator, I can bring this together. But before I do that, I want you to see something very interesting. And what this is saying. If you look closely, this right here is the x-coordinate of the vertex. And since what we're doing here is we're trying to find solutions for x, in other words, find the x-intercepts, okay, for a quadratic, if that's the x-coordinate of the vertex, then what this tells me is find the x-coordinate of the vertex, and then if I add whatever this number becomes, I'm going to get one of the x-intercepts. And then if I subtract the same thing, then I have the other x-intercept. Because remember, quadratic equations or functions are symmetric about the vertex. Remember, the axis of symmetry goes through the vertex. And so then it's balanced on both sides. And so that's the balance right here. This tells you how far you have to go from the axis of symmetry to get to the x-intercept. Bring these together, and you get this equation right here. And this is its form that it's given in all textbooks. And this right here is called the quadratic formula. That's the quadratic formula. You're going to want to memorize this. Okay. X equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. It's usually the little mantra people remember it as. But you remember it however you want. Okay. Some people put a song to it and stuff like that. But this is the quadratic formula, and you're going to want to know it. The quadratic formula is a method for finding the solutions to a quadratic equation. It is used to find the solutions to a quadratic equation. Okay? That's what it's used for. But here's the thing that a lot of people forget. It must be in this form. So in other words, you cannot use the quadratic formula for any other form unless it is a quadratic equal to 0. If I have this, then I can find the solutions using this formula where a, b, and c are the coefficients of each term. A is always the coefficient in front of the x squared, b is the coefficient in front of the x, and c is always the constant. This is how the quadratic formula was developed. And so now the quadratic formula becomes your secondary source for solutions. First thing you do is you try to factor a quadratic. If that doesn't work, use the quadratic formula and go directly to the answer. If for some reason, you really don't need to use the complete the square technique to solve an equation unless it was asked of you to do so. Okay? So there is that. Let's do a practice problem with some of the problems we had from our worksheet. So here, I'm just going to take one of them. Let's take number 1 and example. We'll do x squared minus 5x minus 7 equals 0. So the question is, can I factor this? Are there factors of 7 that will subtract and give me a 5? Well, 7 is 1 and 7. They don't subtract and give me 5. So this will not factor. So I'm going to use the quadratic formula. This is how I recommend that you do it. Every time you use the quadratic formula, you need to say it. You should probably, in the very beginning here, write it out. Okay, so make sure you write it down for your problems. So x equals negative b, and say it to yourself as you do it. Plus or minus the square root b squared minus 4ac all over 2a. Make sure this is all over 2a, just like that. Identify your a, b, and c from your problem. My a is 1. My b is negative 5. My c is negative 7. I recommend that you write down what those numbers are. Then we're going to plug into the formula. But before I actually plug in the numbers, what I'm going to do is I'm going to restate this. And as I do, for every letter, I'm going to put an open parentheses, just like this. X equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. I say it, I put the parentheses in there, because then all I have to do is plug these numbers where they belong. And then again, say it again to yourself as you put in the numbers. X equals negative b plus or minus b squared minus 4ac over 2a. When you're doing the quadratic formula, okay, if you do this, if this was a 5-point problem, this right here gets you 3. By plugging into the quadratic formula correctly, I give you 3 out of the 5. The rest of the points there comes from you simplifying this out and getting the proper answers at the end. Once you have it in here, it's just a matter of following order of operations, PEMDAS, and work this out. Minus a negative is positive. The bottom's going to be a 2. This is 25. Minus and the minus is positive 28, so plus 28. So this is 5 plus or minus the square root. Combine those together gives me 53 over 2. You need to look to see if I can simplify 53. And just so you know, in this example, 53 cannot be simplified, so it is already there. You are done. Here are your two answers. X equals 5 plus the square root of 53 over 2, or X equals 5 minus the square root of 53 over 2. There's your two answers. And you can use a calculator to find approximate values of those, rounded to 3 decimal places if you need be. But these are the answers. Anything else is an approximation, not as good as these. So this is what I'd be looking for on your work. Let's do another example. So here's an example. 4x squared minus 10x equals 2x minus 9. So in this example right here, you cannot even consider the quadratic formula unless you're in the proper form. Remember, the proper form has to be everything on one side equal to 0. So you need to first move these to the other side, and then we're going to add a 9, and I get 4x squared minus 12x plus 9 equals 0. And once I'm here, then you look to see, can I factor this? I don't know. Let's find out. If I can, I need factors of 4. 1 and 4, 2 and 2. Factors of 9, 1 and 9, 3 and 3. Can I get these two combined and add and give me a 12? Well, yeah. 2 times 3, 2 times 3, that's a 6 and 6. If they're both negative, then I get a negative 12. Well, sure enough, I can, can't I? So then I can factor this, and this is 2x, 2x, 3, 3, and they're both minus. Well, there you go, see? It's the same factor twice, so I only need to write it one time. And so then I solve this, and I get x equals 3 over 2. Okay, so there's only one solution. That means that's the vertex. The vertex is at 3 over 2. Now, what does this look like as the quadratic formula? Now that everything's over here, A would have been 4, B would have been negative 12, and C would have been 9. Okay, so x equals a negative b plus or minus the square root b squared minus 4ac all over 2a. Negative 12, a negative b plus or minus the square root b squared minus 4a times c over 2a. I get 12 plus or minus the square root, and this will be 8. So what is 12 squared? Well, I know that's 144. Okay. This right here is 16 times 9. Okay. 16 times 9 is what? 54. Oh, 144. So what happens is the entire square root becomes the square root of 0. Okay. So this is now x equals 12. There is no plus or minus number because that was 0 over 8, which I can reduce down to 3 over 2, which is what we said it was. Okay. So the factoring technique you want to use as much as possible. There's a lot of places you can have errors in the quadratic formula, so you want to be careful on those. There's more examples. We'll do those in class together. But that's the idea of how to use the quadratic formula, how I want you to write it out and use it. Okay, please make sure you follow that, and we'll be good.